want to start now?
Actually, people are joining in, so let's wait 2 or 3 minutes, then we can start.
Yeah, sure.
Okay, so let's start. Let me introduce you to Fatemeh. So Fatemeh is currently a third year's PhD undergrad, PhD student at UC San Diego, and a research scientist at Openmined. Her research interests are privacy-preserving ML, NLP, and hardware and system design for ML. So, as well, she is also an incoming intern at Microsoft Research AI and NCWIT Club UIET at winner. So I'll hand over the mic to Mahathir right now, and we can start the session.
Just a
Thank you.
second, just a second. Sorry, is the screen recording right now? If you can ask Tarun.
Okay, we will record. Yeah, I think Tarun is doing.
Okay,
Yeah,
sure.
Okay.
Okay.
So Fatemeh, you can start.
Yeah, thank you. Thanks for the introduction. So, yeah, I'm a third year PhD student, and I've also been like working on NLP for like as a topic of research for around a year now. So in the first 2 years, I was mainly working on privacy for deep learning, but I started working on NLP like around a year ago, for my PhD work, less than a year. Yeah, so with that, I'm going to like start the presentation. If you guys had any questions later on or wanted to reach out or stay connected, feel free to email me, or you can reach me on Twitter as well. Yeah, and also, right, I have prepared a slide deck, but this is interactive, right? So if you have any questions, feel free to like stop me at any point and ask your questions. The slides are just there to, so that we have stuff to talk about. So yeah, if there was anything, just stop me. And I cannot read chat, so it's good if you just speak up. It's okay. And yeah, so I'm gonna start. So NLP, natural language processing, it's all about text, right? Lots and lots of text. And this is just like a cartoon that I wanted to open up with. If you guys can like read this, it's a fun thing to read. But basically, it starts. It's about how the expression like "I could care less." It's if you want to kind of get the meaning, it means I could care less. But when we say I could care less, it actually means that like I don't care. So it's kind of ambiguous, right? So we want to like just start with how ambiguous natural language can be, and that's one of the things that makes NLP like a challenging task, right? Because language is what we're using to kind of express our thoughts, and our thoughts are complex and not simple. So it's also not simple to process text and natural language in general. So yeah, like an expression like I could care less actually means that I could care less, but when we say it, it means that I don't care. So it's it's hard for us to understand, and like how can we get a machine or something that is automated to understand these types of things, nuances. So a quick you can see some applications of NLP here. So these are just like some high level words that we can understand, but throughout this presentation I'm going to kind of dive deeper into natural language processing tasks, some of the tasks that people are doing research on, or they're like using them in industry, And we'll go over them. I'll mostly just provide some insights on the type of tasks that people are working on. And yeah, and then we can, have discussions about them and get deeper into if like there's any of them that you would like to know more about. So with that, let's start with the like most kind of initial concept that we have to discuss. So I assume like we have text, we want to do something with some like natural language. How do we do it? We have these bunch of words. So like the simplest, oldest thing that you can think of is like to have something like a dictionary that maps words to their synonyms or maps the relation between words, right? So you have this text and you want to know what the topic is, or like you want to get the overall meaning of it. You can have this dictionary where you can just like, relate each word to like a simpler word or like what it is a subset of, and then using those things, you can figure out the whole topic of the text. So like synonyms, hypernyms, like if we have good as a noun, like what does it look like as an adverb, what does it look like as an adjective, all those types of things. So there is this resource, it's like a dictionary called wordnet, where you can type a word and get these types of information about it. But the problem with like using such a resource, such a construct, is that it's good, but it misses some details, misses some nuances. Like a word like proficient, it can mean it can be a synonym of good, but it's not always that in all contexts. It could mean different things, so it's not always meaning good. And also, like, as language progresses, that like every day there are new catchphrases, there are new slangs, like wicked, nifty, genius, or like, I don't know, different types of spellings of words that we use. So with the evolution of language, you also need to keep updating this, and that's going to take a lot of labor. And it's also subjective, right? Maybe I think like one word means something, someone else could use it differently, have different thoughts about it. So it's not really easy to keep such a resource and work with it. So we want to have something that is like more automated, and it also like shows relationships better. And also we would like to be able to like process it, right? So it's better for us if it's in like its numbers, right? If it's something that we can compute on. We cannot like compute on these words themselves. So in order to kind of solve this problem, one really easy solution that comes to mind is to just like encode words. And the easiest type of encoding is one-hot encoding, right? So like assume you have a vector and you want to show your word with this vector. The simplest thing is that you can have a vector of the size that is same as your vocabulary. And, just like if it's hotel, then like the kind of, if you assume that you have these little bins, only like turn the bin for like motel to 1 and the others to 0. Or like for hotel, it's like another bin, you just turn that to 1 and the others are 0. So that's called one-hot encoding, because at like all times there's only one of these kind of these positions that is hot, that is set to 1. So this is like one-hot encoding. It is a simple, like it's kind of the simplest type of encoding that you can imagine. And it kind of works, right? You can encode any word, but there are some problems with it. So yeah, do you guys like, can you make a guess of what could be wrong with such a thing? Like, what is a problem that you would have if you do this? If you want to like encode all words like this?
The size of the vocabulary might be too big, so yeah.
Yeah, exactly. The vocabulary could be too big. Like you can have 500,000 words, and then like how are you going to where are you going to keep them? And if you want to process them later, you're going to like feed them through a neural network or something, then how are you going to fit everything like in your GPUs, in the memory? So then you're going to have a problem. So what people do to, like, this is one problem, but there's also another problem, which is not such a logistical problem, more of a practical problem. So you let's say like you want to search for Seattle motels on like in Google, but you're searching for motels, right? But you're also looking for hotels or any types of stays that you can have. But if Google embeds it using this one-hot encoding, then motel and hotel, they are orthogonal, right? The vectors are orthogonal, which means that, like, their multiplication is 0, so they basically have no relations. So with one-hot encoding, you can't really show relations between vectors, right? If two words are synonyms, how are you going to show that? Or if like two words are actually like antonyms, or they're like in the same group, they're very much different, how do you show that? So it's better to kind of insert a notion of similarity into our encoding. So that's kind of what gives way to using word embeddings that are trained. And like a word embedding could like have any arbitrary dimension. And what kind of makes different words have different embeddings is that like those the numbers like in the vectors that in each dimension, those are different. So like for banking, you're going to get something that looks like this. Now, if we train one of these, like regardless of how we train them and how we get them, once the training is done, you get an embedding for each of your words. And there are like lots of embeddings right there out there. But like once you do the training, you can like visualize your words. And like if you see need and help are close to each other, or like being, been, had, has, have, these are all close to each other. So the good thing about training embeddings is that once if you visualize them, they also kind of show the meanings. So you can get that notion of similarity here. Like if you change one of the elements in one of the vectors, then you're probably going to end up with a word that is close or related to the original word. And how they train these things, I don't want to really like get into math stuff like today. So just imagine that like you have this huge corpus of data. You don't really need any labelings. You just feed the data to your model, and there's not really a model. It's like you have vectors of weights for each word, and you want to train them, right? You want to train these vectors for each word, and what you do is you try to maximize the probability of each word given its surrounding words. So yeah, like here, what you're doing is for into. So you just try to maximize this, and you train with this kind of loss function. But that's yeah, that's not really like important here. Just imagine them as we have these vectors for each word. And okay, so here we're seeing a set of embedding visualizations for gender. So we have visualized words like brother, uncle, nephew. You can see man, sir. And if you take like if you step the same amount from each of them, if you like move, if you add a vector to the original word, you're gonna get mapped to like the same word but for like a female role. So you're gonna get mapped to like niece, sister, woman, madam. So that's like kind of that's a nice thing that people have realized, that once you train these models, if you can have these vectors that by adding them you get mapped to like something similar but kind of different. So this was like for genders. We also had these same thing for superlatives, and like you have a slow, slower, slowest. They all look similar for different words. So it's kind of like an interpretability thing, that like it shows that what you're learning, it makes sense. Yeah, so this is a set of embedding called Club Embeddings. So these visualizations are for that. I think it's a 2014 paper. I'm not exactly sure, but we have people normally use Club embeddings or word-to-vec embeddings for research, and also like for work. That's what people use if they want to have embeddings for each word out of context. But lately, I think you might have heard like BERT, which is kind of a contextualized embedding, or ELMO, where you can have context. So here you're getting a vector for each word separately, so it doesn't matter where your word is placed. But with like BERT and ELMO, that I'll talk about more towards the end of the presentation, there you care about context, right? So if you have the word, I don't know, if you have, let's say like a word that has two meanings, something like, the I could care less, based on the context, it would, let me make a better example. That is not a good one. God, give me a word that has two meanings. Like the meaning can change in different contexts. I can't think of anything right now. But anyway, based on the context, the embedding is going to change. So you're not going to have a static embeddings for each word. Based on where this word is used, jaguar. So like jaguar, If you're like talking about I saw a jaguar in the jungle, so then it's the animal. So you get one embedding. But if you mean jaguar the car, like I bought like I drove a jaguar today, then you need another embedding, right? Because these two words mean different things. So if you use a contextualized embedding, you're going to get different embeddings. But if you use these static ones, which don't rely on the context, then this jaguar is going to get mapped to the same word no matter where it's used, the same embedding. Sorry. Okay, so this was all about word representations and embeddings. And this is kind of one branch of research in its own. How to get better embeddings, how to get embeddings that lead to better models, how to get interpretable embeddings. So there's still research going on in this. I think although like we are at a good place kind of, but there's still research going on, especially in terms of like sparse embeddings where you can have more interpretability. You can, have like more elements that are zero, and, like by changing just one of the dimensions, you can, like change through words, hierarchical embeddings, those types of things. So there's still research going on word embeddings. So now I'm going to talk about another task, which is like dependency parsing. So what do I mean? Like when you read this, it says doctor, no heart, cognitive issues. It's like, if you feed this to a model, like what is it going to interpret this to? Like doctor says that like there is no heart and there are cognitive issues, whereas we know that this is like doctors said no heart or cognitive issues, right? So we know this, but a machine might not like really get this. We are understanding the dependency between different words and how they relate, but we kind of have to make sure that our model also understands it as well. Or another like example here, it's a bit gruesome, but it's like mutilated body washes up on Rio Beach to be used for Olympics beach volleyball. So we know that the beach was supposed to be used for the volleyball, but it kind of looks like that body is going to be used for volleyball. So it's like it's a bit ambiguous. We understand it, but again, we have to kind of make sure that the relationship between words are represented well. So this leads to another kind of task, which is a task of finding dependencies. And it's kind of like, I don't know, maybe if in literature, you guys might have seen this, that, you have like different words. You try to say like, what is the role of each word? Like it's the object, subject, and how the words relate to each other. And you make these trees out of it. So this is that task. And there's also like research going on. I'm not really familiar with it. I've never done it. And I haven't really read many papers about it either. Because it's mostly kind of, it has more to do with linguistics. I mean, it's still kind of an ML problem too, kind of an NLP problem, but it's mostly on the linguistic side to how do we parse sentences and how do we find a relationship between different words. But it is also an active area of research. So the third task that I want to talk about, which is kind of been my focus as well in the research that I'm doing, is the task of language modeling. So language modeling also motivates the introduction of the family of neural networks called recurrent neural networks, RNNs, that you've probably heard about them. So let's kind of get into it. So language modeling is a task of predicting what word comes next, right? So you say the students open there, and you want to predict the next word. It could be books, laptops, exams, minds. So yeah, you want to have a context, and then you want to predict the next word. What is important about language modeling is that you're just predicting like the next word right now. So you're trying to predict one word, and you're also provided with this context of the words that come before. So language modeling traditionally does not look into the future. So it's not like I give you the students open their blank and something, and you get to like look at both future and past to fill the blank. It's only like you have the past and you want to predict the next word. So like mathematically, it's basically trying to find the word with the highest probability of this next word given the previous context that we have. So if we have a model that can do this, it can give us a probability for each word. So like right now, maybe if we run this through a language model, the probability of books would be like 10%, laptops 8%, like exams 6%, mines would be 5%, and like opened their flowers would be, like 1%, because it's not something that we say. It would be like 0.5%. So it kind of ranks all the possible words in the dictionary based on the probability of them being the next word. So yeah, that's what a language model does. Okay. And you can all, I have some went through this part. Yeah, you want to assign a probability to the next word. And also another thing that you can do is that you can use a language model to assign probability to a piece of text. So you can both use it for like predicting a next word if you have a context, and you can also use it to kind of assign a probability to a sequence. And this is good for like, imagine you have a bunch of text and you want to see if some of it is maybe like generated by a bot, or maybe it's just like there's some nonsense in it or some random strings. So if you have a good like a language model that is well trained, you can feed this sequence to it, and it will give you a probability of how probable it is that like this sentence exists within this grammar that we have. So if you have a good language model, we can also use it to kind of detect if a text is natural or not. Or if it's like there's something wrong with it, maybe. And how you do it is you basically multiply the probability that the model generates for each of the words given the context that it had. And this, like with language models, one thing is that they tend to memorize. So I'll talk about their structure, but they do tend to memorize. So if you like feed a bunch of sequences to language models and you get like some of them have highest probability, that means that those sequences are memorized more. So this is kind of a new area of research that people are looking at into like trying to characterize how language models are memorizing, because we know like you've probably heard like GPT-2, GPT-3, and how they might have memorized people's sensitive information, and how there are many kind of risks with them. So you've probably seen it in the news and like Twitter that there are a lot of things that could go wrong with large language models. They could kind of learn offensive things. They could generate offensive sequences, aside from just generating people's secrets as well. So we have to be really careful with them. But here, like, let's assume that we're dealing with a benign setup. One example of language modeling is the keywords that you use, and you like type something, I'll meet you at the, and it kind of gives you three predictions, three top words that could fill the blank. Or when you're searching in Google, that's also like another language model at play that is predicting the next word for you. Now, so language models are not necessarily neural networks. There are different types of them. So one of the simpler types is n-grams. Again, back to the students open their example. You want to kind of predict what the next word is. And if you use an n-gram, n-gram could be unigram, bigram, trigram, 4 grams, it could be any n. And you start looking at kind of sequences with that given length. So if you're looking at bigrams, like this student is 1 bigram, students open is another bigram, and open there is another bigram. And language modeling using n-grams is basically you kind of have these series of bigrams from your data, you extract them, you have this data set, you extract all the possible bigrams or trigrams, and then during prediction, you kind of look at how many bigrams give you a certain word. So I think I have this slide for that. We'll get to it. But basically you collect the statistics, and then you see that, okay, most like 90% of the times when I see opened there, the next word is books. So I'm going to predict books. So it's basically you have memorized these series of words, and you look at the statistics, whichever of them is more probable, you just fill the blank with that. Now there are problems with this setup. One is like, where am I going to like put all these n-grams, right? Like, how do I do this? It might be if your like n's are huge, it could be expensive. How you're going to save them and how you're going to look them up. So that is a problem in and of its own. But another problem is the sparsity. So one thing could be that you don't really have, like, you're seeing a new sequence and you don't have it in your like n-grams that you have saved. So what do you do then? Or one thing that you could do then is that, like, if it ends up being 0, then the overall count is 0. So you're going to end up with a division by 0. So you can add this a small delta for everything. It kind of smooths things out, but still you're not getting anything meaningful out of it. Or you could just, if you see that, like, if you're looking at, 5 grams and you couldn't find it, then you can resort to 4 grams or 3 grams. But then you're not looking at enough context, right? So maybe you predict something that doesn't really make sense. So that is like one problem that exists with n-grams. They're not really complex. They cannot represent all possibilities. So one, like with deep learning, we're using like deep learning everywhere. So obviously we're going to use it here as well. And I don't know how familiar you are with RNNs, but look at them as these black boxes where you can kind of feed a word and they can keep a kind of state for you. So like you can keep feeding sequences. They'll give you an update. You feed the next one. They give you like a hidden state, an output, and you kind of, feed it back. So you have this thing that has this kind of a state and you can feed it sequences, as opposed to like CNNs or just simple fully connected networks when you just like feed everything at once and there's no sequence to it. Here you can keep, feeding everything one by one. So like an example is like the students open there. So you feed to the model, it gives you a hidden state. So these red ones are basically one model. We have just unrolled it. So it's like kind of you're like looping back to it. So you're feeding the hidden state back to the model, and then you're feeding the next word. And then you're feeding the hidden state back, and again, the next word. And like you feed your whole, like the sequence, the students open there, and then the model gives you a prediction of what it thinks has the highest probability for being the next word in the setup. So I don't really want to get into, the details of like different, sorry. Okay. Different language. I think. Okay. Different language models, they're like, RNNs are like vanilla recurrent networks. You have LSTMs, you have groove cells. We'll talk about transformers. So there are many different types of language models, neural language models. But regardless of that, we want to see some fun examples here, that, you have these language models that are trained on a certain corpus, and we have just let them generate text. So like if you train a language model on Obama's speeches, then you're going to get this text here. So like the United States will step up to the cost of a new challenges of the American people that will share the fact that we created, so it's kind of coherent, but it's not, right? So one thing about recurrent models in general is that they're not good with remembering like long sequences. So as they go along, they tend to forget the beginning of the sentence. So if you're generating long sentences with them, it sometimes ends up that they don't make much sense. So again, they were attacked. So you can totally see that this is like Obama's style, but the sentences don't really make much sense. Again, this one is like on Harry Potter. So if you're like a Harry Potter fan, you can, you can like read it. The plot doesn't make much sense, but again, it's like obvious that it is Harry Potter text. And you can also like use it to generate recipes. So this is like a very crude example, but there are also like research papers on how to like make recipes that actually make sense, or in general make instructions that make sense. So we want to like tell people how to assemble a chair or something. How can we like have these automated generation of these texts automated, and you also want them to make sense. So yeah, here like this recipe is like I wouldn't make it, but yeah, it's like cookies, casserole, weird. But again, it's like fun to play with language models, and this is also another use that they have. Okay, so with language modeling, we were predicting one word, and it was like we wanted to basically model the whole language, the grammar, and be able to say if given a certain sequence, the next if like a certain word is going to fit into this sequence, and what is the probability that such a sentence occurs. But with machine translation, what you're doing is that you want to translate one sentence from one language to a sentence in another language. So you are still kind of doing that generation that language models did, but here you try to like take in one language and then generate in another. So yeah, you can see like an example of French text that is translated to English here, and we want to we want to automate this. So how do we do this? So before 2010s, before like deep learning happened, people did statistical machine translation, and the whole idea was that you use like Bayes rules, and you break down, you want to like predict the probability of getting a certain word given this other language, like given this other sequence in another language. So you have this probability of like x given by, but you're also you want to multiply it by the probability of y, which is the language model, because you want the model to write in a good kind of destination language, right? So you also have this language model that just gives you the probability of the text, and you also have this translation model that would keep the semantics, keep the fidelity of the meaning of the text. So you want it to be fluent, and you want it to be to have high fidelity. So you have these two probabilities, and before neural networks, these were all done with the statistical models. So these models, they had this huge research field, but it was very hand tuned and hand optimized, because you want to find all these different pieces of different pieces of different like statistical methods, put them together and try to get these good models. And it was really hard to like make them, and it took a lot of time, and it took a lot of engineering. So it wasn't really it wasn't simple at all. But then in 2014, and you have these deep learning models that can give you the probability of anything based we all know there's a lot of things wrong with them, but yeah, they can like generate probabilities for you. So coming back here, you can have both your translation model and this language model. All of them can be deep learning models, so you don't really have to worry about how you get these probabilities. So yeah, there was like this huge thing called deep learning that happened, and now not now, then people started using RNNs. So for machine translation, what you have is that, so the red part, if you remember, this is similar to a language model. So you have like one encoder here. So this is only taking in text from the source language, and it's encoding it, and it's giving like one final representation to a decoder model, which is now decoding that. So it's like you have two language models kind of, and one of them is taking care of encoding, the other one is decoding it in this to the destination language. So like we have this French term, il m'a emporté, which means like he hit me with the pie. And you get the translation from this recurrent model. You feed the source language token by token, and you extract the the translated sentence again token by token. And yeah, you have like both decoders. So you have an encoder-decoder setup here, and this is like simple RNNs. You can replace this encoder-decoder setup with anything. You can put transformers here, which we'll see in a couple of slides, or you can just like replace the the cells with LSTM, Guru cells. It doesn't really matter. So this type of modeling is called seek-to-seek or sequence-to-sequence modeling, and it's not just for translation. So we're talking about it in the context of translation here, but there are a lot of NLP tasks that deal with seek-to-seek. So you have summarization, that you have this long sentence, you want to get this long text, and you want to get everything summarized in like a couple sentences. You have dialogue generation, where you get like one sentence from one person, you have to like generate another, and so on. You have parsing, which like you can as we talked about, like you have this sequence and you want to generate those series of arrows. And you also have code generation. That's also a field that you have. You want to talk, like write your code, write your algorithm in like plain language, and generate Python code. That could be another thing. We also have question answering, which is kind of like dialogue. So there's a lot of different tasks that use seek-to-seek modeling. Now, what are the advantages of using NMT, neural machine translation? It has good performance. It's really fluent. You can look at a lot of context, and you also get to use the phrase similarities because of the embeddings that are generated when you're training models. So you can like fit similarities better. And you can have just like this one neural network that does everything. You don't really have to intervene. You just have to tune your hyperparameters, and everything seems simpler. But what the problem, like one problem is that it's not interpretable, right? So it's really hard for you to debug. You're training, you only have these hyperparameters. So if something goes wrong with your model, it's really hard to diagnose it. And it's also like difficult to control. You can't like give rules or guidelines, right? It's whatever the model learns. So if you want to like apply grammatical rule directly, then it's not so simple to incorporate them. There are, I think, there are some there's some research that does this, that tries to apply rules, but in general, it's not something that is like straightforward. And you also have safety concerns, right? Because what if it translates into something wrong? We're going to see some examples, but there are a lot of things that could go wrong with this. So one is, you say paper jam, and you know that it means like when your paper is jammed in your printer, but it gets translated to, I don't know the Spanish one, but anyway, it's translated to marmalade. So it's like paper marmalade. So, you don't want that. That doesn't make sense. But this is a benign mistake. Another thing that has that this exists in like a lot of languages, like we tried it with Persian as well. So there are languages that are you don't have genders in them, right? So the pronouns that you use for like, you don't have he or she, you just have like one pronoun that is unisex. So if you like write sentences in them, you like in that sentence, you like write a sentence that this person is a nurse and like this person is a programmer, then the translation ends up being biased. So like you see here for like, I think it's Malaysian, you get she works as a nurse and he works as a programmer. So there are lots of like, or like she's, he is a doctor. So when it's translating, it doesn't use she. So the model is kind of biased. So this is one dangerous thing that could go wrong, and it could impose bias. Another thing is that, if here an example is like you set your source language to be Somalian, you write this weird sentence, and then it gets translated to as the name of the Lord was written in the, it's like weird. How could this translate to that? So again, it's uninterpretable. So it's like really hard for people to debug why when they write this, they get this certain type of nonsense. And okay, so with this, I want to like segue to attention, which is again another thing that is used for it's used for many tasks, but like in translation, you can think of it as, like when I'm translating a certain language, like the certain sentence, like, he hit me with a pie, and I have this parallel French sentence for it, which words which words correspond to each other. How can I find this correspondence, and how can I know where to pay attention to, where to focus on? So this is what attention is. It's kind of like a weighting on words, on like when I'm looking at this word, what word in this other parallel sentence should I be looking at? And attention has really like transformed a lot of things. It really helped get better accuracy on different types of tasks. But one of the things that is known for is like the transformers, and the paper is called Attention is All You Need. So in transformer models, you don't really have that sequential recurrent language modeling type. It's kind of like a feed-forward model. It's not the same though, but you can like feed your whole entire sentence at once. So it's offers more parallelization. So you don't have to like feed the sentence token by token, which is really good. Like you can better use GPUs. And also it can remember context better, because with a recurrent neural network, you didn't really have a good memory. So if you said something 10 words away, it probably wasn't going to remember that. But right now you're feeding everything at once, so you have a better chance of capturing longer sequences. So that is what kind of sets transformers apart from recurrent neural networks, and why they are kind of better. But one problem, I'm sorry, not a problem. Let me first explain what transformers are in, how they like work. They use this mechanism called self-attention. So if you're feeding a sentence, like I kicked the ball, with translation, you had that sentence in another language, and with attention, you would kind of try to relate words into the different language, but here you just have the same sequence, but you want to know like which word you need to pay attention when you're like looking at the same thing. So kind of like attention with who, I kicked the ball. So when I'm looking at kicked, I should have a strong connection to I, and the other ones, I don't care, because this is like who. I want to know who did this. Now, did what? Kicked. So again, I look at kicked here. So what I do is like the red head. Sorry, yeah. So basically, it's like I try to find how different words in a same sentence relate to each other. So I kicked the ball. Like what did I kick? And did what? All those things. So I have different attention heads for different ones, different types of relations. And this is the transformer architecture. I don't know if you're like familiar with them or not, but it's kind of more complicated than I can just explain them right now. You really like need to read about them and like think about it and write down. It's like it has its own process for actually understanding how they work. But to put it simply, they also have this encoder decoder setup. So the first module that you see to the left is the encoder, the second one is the decoder, and they are very similar. You can assume that it's like a simple feed forward network with fully connected layers. So you kind of have dependencies between all words. So if you have like a sequence of length 10, then you have all possible 10 connections. So you have assume like each of the tokens are related to each other. So you have this 10 by 10 connection. So if you have long sentences, you have long sequences, then you're going to have this kind of computational issue here, not computation, also memory, because you have all these connections. So you can't really, look at large windows, because compared to RNNs, you're going to need like a lot of memory to be able to handle all these connections. And yeah, so here I want to like look at some language models and what happens with so the first language model is actually a recurrent one, but then you have GPT, you have BERT, and you have GPT-2. BERT is not really a language model, but people use it like that. Anyways, the last three of them are transformer models, and you can see like how long it takes to train them, how big they are, and yeah, it's like you need a lot of resources to be able to deploy these types of language models. And these three are all transformers. So now what is BERT? BERT is like bidirectional encoder representation from transformers, which basically what it means is that you use a transformer architecture to train word embeddings and representations. But this is the one that I mentioned at the beginning. It's like you have this context, you're looking at the words around you. And I think I have a slide here. Yeah, you can see like BERT, GPT, and Elmo here. So for BERT, you have all these connections with future and past. So when you're training BERT, you're also looking at the next words. And BERT gives you embeddings, it gives you representations. It's not a conventional language model. So you don't like feed it a sequence and it will give you like what the next word is going to be. BERT is normally used for generating representations, and then people like put one layer, like one projection layer, fully connected layer, to use it for any downstream task like classification or different types of things, detection, different things. OpenAI's GPT is a language model. So if you see with the language model, you can only have one direction. You cannot really look back because you only have the past. When you're language modeling, you don't really know what the next words are. You just want to guess them. And Elmo, again, Elmo is like BERT. It's contextual word embeddings, but Elmo has RNNs. So again, if you see like you don't have these cross connections, it's using simple recurrence. And okay, so part of this is slide, but so here I wanted to like talk about the career parts. Like we saw some tasks, but where are they used? Like, do people really care? Like if I go into NLP, am I going to get a job? So right now, I think NLP is actually one of the hottest kind of fields of CS to get into. And there's lots of research. So if you're into research, there's a lot of cool research going on. And also like in terms of products, there are a lot of products. If you think about the stuff that you use daily, you'll realize that most of it is actually NLP based compared to like computer vision based. So I want to just say some examples and maybe you noticed them, maybe you didn't notice. So like Microsoft, you're using Office, right? So Office might not look like something that is using NLP to you at first thought, but Office, like for doing many things, they do use NLP. So one of them is that they if you use like if you use like Word docs online, and you can like leave comments, so then it can generate some suggestions for you. It can extract tasks. So if you're using Outlook for your emails, you get predictions for like what the next what kind of, like, if someone sent an email to you, basically it can extract tasks from it, like you have to do this, you have to do this. And it can also sort your tasks. So if you use like the a task related widget in Outlook, it can kind of give you a recommendation of what is a better order for you to like do your tasks in. So there's a lot of things that these are all NLP tasks. And Microsoft also has like partnerships with healthcare providers. So there, for like if you're looking at medical like records, prescriptions, then you want to like be able to like predict what the illness might be. You're using NLP. And also another thing is like chatbots, and like you have a prescription, you have a question, like you want to know how to use your prescription. You can like just write it to a chatbot. And there are also other types of chatbots that people who are like dealing with mental issues like depression, they use them. They talk about their days. So there's like a lot of different things like that that are all using NLP, and they're becoming more prevalent every day. And also Microsoft has a keyboard called SwiftKey, which again for like predicting the next words when you're typing, or like giving you better suggestions. Those are all using NLP. And Google, again, like Google, I think this is the one that we can most relate with, because you log into Google, whatever you search, when you're asking questions and it like brings you the answer, like you're asking what is the population of I don't know, like a certain country, or what is the area of the earth, or anything like that, it gives you the number and highlighted. That is like Q&A. So like apart from just language modeling for guessing your questions, it's also doing Q&A. It's going through all this text and finding one answer for your question. Also, if you're using Gmails, when you type, it gives you these really good suggestions that you basically don't need to write your own emails anymore. So that is a smart compose. That is, again, a big NLP thing. Spam detection is normally uses NLP. Your emails, when you get them, like you can see that like there is this main thing, there's promotions, they're all getting classified and also sometimes even sorted. That's, again, an NLP thing. Or sometimes you send an email and 5 days later it comes up and it says, do you want to follow up? It detects that you've asked something from that person and it needs following up. So again, there's a lot of NLP going on there. The Google keyboard, Gboard, that has language modeling tasks. If you see like Google News gives you some summarizations of news, it also gives you recommendations. So those are all different tasks. And again, with Twitter, you have a different set of tasks. Your timelines, they get sorted in a nice way. You see all related content put together. You can say that I don't like this type of content. You see less of it. And also like Twitter has this whole thing that they have to, find misinformation. They have to find a hate speech and, try to like fight hate speech, try to remove anything that could be threatening. So again, those are all different types of tasks that people are dealing with. And there are also lots of startups. You might have used like Duolingo, Hugging Face, Grammarly. So there are all these different startups that are working on NLP. So if you like think about it, there's a lot of use case in our everyday lives. And research-wise, again, it's like very hot. There are many cool different types of research that people are doing. So so I think it's a really good time to be doing NLP. And so if there are any questions about any of it, sorry, I went on talking for a very long time. Feel free to ask and we can discuss right now. One thing is that like about the Microsoft stuff, I've done one internship with their like email smart compose team, and I'm doing another internship this year with their SwiftKey. So if you guys are like, if you have questions about that, that's also, we can talk about them. So yeah, go on.
Fatima, there have been a few questions in the chat box. Like, let's start with the technical ones. One question is like, as we talked earlier, RNNs don't provide a coherent generation due to low memory. Would context clues help with better semantic cohesion? What other approaches could get us better grammar in our generations?
Sorry, can you repeat the last part of the question? The better what
What
generation?
what other approaches could get us better grammar in our generations?
Better grammar?
Yeah.
Okay, okay. So with text generation, if you're just if you're predicting just one word, so you don't want to like predict a sequence, then if you just use a simple language model, you're normally going to get good grammar, right? Because it's only one word and it's going to give you a probable word. So you're probably going to get a good sentence, but it becomes more complicated when you're trying to predict a sequence. So then for getting like good grammar or like getting a meaningful sentence, people try different decoding mechanisms. So one way, like the one that I talked about, is called greedy decoding. You just take the word with the highest probability. But if you just do that, like for like multiple sentences, you take the one with the highest probability, go on, then what happens is that you might not end up with the best sequence. So there are different decoding mechanisms. You can also use beam search, where you kind of like with the length of 2. And you don't just look at the best one. You like look at 2, and then there's like this tree formation. So people use different types of decoding mechanisms to get better sentences. So that is one thing you can do. And other things to get good grammar, I mainly know this one. You can also just use like better, bigger models. That's what everyone is doing. But yeah, that is like the most, the most used one is like trying different decoding algorithms to get better sentences. Yeah. Oh, and also, yeah, contextualized models, they definitely end up giving you a better, like a more meaningful sentence. That is also true. So if you know the context, then you're probably going to get a better, both in terms of grammar and meaning sentence. Yeah, that's why people use them.
Okay. Avril, I think that cleared you out. Oh, do you have any
Sorry, I think
follow-ups?
that, uh,
Yeah, it was a question from Aviral, so I was asking him if it cleared his out. Yeah.
uh, okay.
So next question is from Prashant. He says, what techniques can I use if I wish to extract phrases out of the sentence? Example, I am doing great. Would extract doing great as the phrase?
Oh, so you want to extract phrasal verbs?
Yeah.
Um, okay, I see. Um, So there are, okay, I can give you like two answers. One is that depends if you want to do it for like a task that you're doing, or if this is like a research thingy that you want to get better accuracy. But if you just want to do something simple, like you have a project, you want to just extract the stuff, you could use, there's some tools that deal with language. So one of them is called NLTK, and there's also another one called Spacey. It's like SPACY. These tools, they mostly use rule-based things, so they either already know the phrasal verbs, like most of them, so they can extract for you, or they have like these types of dictionaries that could help, and they automate things. So normally for parsing and like cleaning up data sets, we do use these tools. I don't know if they do have phrasal verbs though, but that is one thing you can try and come up with some rules. And this would be simple, quick fix. But if it's like a problem that you want to look at research wise, I would look into the parsings. I can yeah, you can email me. I know some papers. I haven't really worked in the area of parsing myself, but I can lead you to some of the papers, and looking at their citations, you might be able to figure something out. I don't really know how people do parsing, so yeah, I'm not sure, but I can send you the papers. Yeah.
Okay. The next question is from Karina. There are many topic modeling models available from starting from LDA to big ARTM. Which one is the best in the approach that you suggest?
For like topic modeling, what is the best approach in
Yeah.
general, like comparing different things? Yeah, okay, so as you mentioned, there are like many different methods. There's simpler methods, and there are like neural methods. So it really depends on what you mean by best. Because if you have like a simple, if you have homogeneous data, it's like all nice and clean, you know, it's not like Twitter data where there are many people with like different types of writing. You have like everyone is written everything neatly, like the 20 news groups data sets where it's like news extracts that have been cleaned up. Then like simpler models, machine learning models, things like LDA, those would work because you would put in, you know, like less compute, and it's like, you know, simpler, it will work for you. But when you have like more complex text and you have like more heterogeneous text, then it becomes harder, right? So then you might want to use like neural models. When there are more nuances, you want to use a more complex model. But again, like it also depends on how much computation you have, how much you know, how much time you basically want to spend. So these are all like the definitions of what you mean by better. But yeah, but I would like, if I wanted to approach such a thing for a research purpose, I would like start with a simple neural model. I wouldn't really go to like a complex one, simple one, but and then adjust accordingly. Yeah, that is what I would do. But again, you have to like be aware of all the trade-offs, right? Because with like if you're using a neural model, it's not really that interpretable. So you might end up with biases, different threats. So you want to consider those. Yeah.
Okay. I think Prashant that cleared it out. Okay. So, Fatima, can you just share your email address in the chat box?
Yes.
Yeah, okay, I'm gonna stop sharing. Why stop sharing? Let's pause.
Hi, can I
Yeah.
write the beginning?
Oh, okay. Let me. Okay, so let me write my. Um, mm, yeah. So yeah, feel free to like email me and I'll send you like I have a lot of papers and different things. So yeah, if you have any questions, I can like, you know, lead you to some related papers. Yeah. Yeah.
Okay. So, Prashant also asked like, okay, Karuna, do you want to ask something?
Yes.
Yeah.
Thanks for taking up the question and thanks for asking, Fatima. I suppose
Yeah.
I'm pronouncing your name correctly. So basically, I wanted to do it on a research purpose itself. I have tried LDA and similar models that are available, but I didn't really get better accuracy in any one of them because I believe that it was because LDA only takes into account the numbers and not the contextual data.
Mhm.
So, just for that, I mean, just to take into consideration the context or the semantics of the sentences, what would you suggest that I should use for topic modeling?
Okay, so the big RTM that you mentioned, I don't know what this is, but if I wanted to like deal with this problem, what I would do is like I would use BERT to give me to kind of give me embeddings for my words. So you know, like you have your corpus, and first you have to like get an embedding, right? So instead of just like using a simple model that would give you, you know, without context embeddings, I would use BERT that would consider the context and give me like embeddings for all my sequences, and then I would build like a simple maybe 2-layer feed forward network on that. So I would get the BERT embeddings and then feed them to a neural network and then train and then freeze the BERT embeddings and just train this like 2 or 3-layer model on top of BERT.
Okay, okay.
Does that,
Great.
yeah, that's what I would do.
Yeah, I guess I'll try that and maybe I'll get back to you on your email ID.
Yeah, I'd love to.
Great. Thank you so much. Thank you.
Sure.
So there has been another question from Prashant. He says he's in final year of undergrad computer science and want to get into the field of research and is currently working as a research assistant. So what would be the pathway to have a career in research? What extra can I do if I want to get an admit from high ranking universities?
Mm-hmm. So yeah, so things that you can try is it's good that like you're right now doing research. So if you could like do a write-up of what you have done, you know, submit it to a workshop, present it so that you can gain more visibility. And it's like workshops are like really good places, especially for junior PhD students, undergrads, and even like senior ones, because there's like if you're like at a big conference, it's harder to get the work in a short time because you don't necessarily have that much time, right? You're like applying next year, the year after that, so it's good to like do small projects. If you have friends who are also like they want to help you, or if you're like working with a professor, they're probably already PhD students. So working on small projects that could lead somewhere, even like a workshop paper in the short amount of time that you have, that's good. So maybe do something that is like less ambitious if you don't have enough time, or like something that even if it's ambitious, you can break it down into smaller projects where you can present it as a work in progress in workshops. I think that's a really good thing, because conferences, they are big, right? Especially in ML. And the good thing about workshops is that they're focused on a small thing, so you get to see a lot of people who are working doing similar things, and people normally attend workshops that are related to them. So there is a good probability that you might meet some possible potential advisor. You might run into an advisor in this workshop and they might see your work. So that is good. That is one way that you can build connections with people, meet new researchers. So that is one thing I would suggest. Definitely like submitting your work into workshops and trying to just attend workshops just to connect with people, even if you don't have any work. That is one thing. And another thing that I would suggest is, so once you're applying, the most important thing, honestly, when applying is to just have some experience of research. I'm not saying that, if you don't, like, it's normal not to have any research experience, but it's good to have some because it helps you to like talk about your work in your SOP, in emails that you send people. So it's definitely good to get some research experience. And secondary to these things, it's like people sometimes really stress out about, GRE or like the language scores. Those are honestly the least important things. So if you have like little time, I would try to get some firsthand research experience instead of worrying about my, language exams. Because those, like, as long as you get the bare minimum, it's okay. Like, no one is going to be like, wow, this person has, like a really high GRE score, I'm going to hire them. That is, or like this person doesn't have the highest GRE score, I'm not gonna hire them. That's not really a game changer. So that's one thing. Try to like get more researchy or just any type of experience. And another thing is that if you have done cool projects in your courses that, you're like, there's some courses that we do and like we're proud of, they have projects that might not be that difficult, but it's like we really learned something from them. I think that's also good to like put those on your resume and kind of explain about them, that, I did this, I used this, because again, like as undergrads, you don't have much research experience. So it's good to show whatever experience that you do have and whatever you have learned, especially like course projects. Those are really good things that you can also mention in your resume. And it's also like sometimes helps if you have like good reports, you can upload them to your website, because they show your like writing, and b the way you think, and it's just good to share them as a profile. You Sometimes people ask me like, oh, I don't have a GitHub, I don't have lots of projects. That, at least when I was applying, that wasn't really important, and I don't think it still is. So don't worry if you don't have like lots of open source projects or anything. That's not really that important, I'd say. What else? And it's also really important to reach out to people. If like when you're applying, try to email as many advisors, read up their work, and really in your emails, don't just be like, I really like your work, like, are you hiring? Try to try to show that you have really understood their works, and like be like, this paper, I really like this part of it, and I would really like to like work on this aspect of it more. This would definitely get an advisor's attention, a potential advisor. So like read their papers, like read the abstract intro, like the body of it, and then also read the discussion and future work section, and see what they say is like good for future work, and try to pivot your emails around that. Like be like, like this unsolved problem that you mentioned, I think like I would really like to work on it, something like that. So yeah, these are the main things that come to my mind.
Okay. I think Prashant, you must have gotten a good idea about what to do now. And
Yes,
there's one.
thank you, Archit, and
Uh,
thank you, ma'am. Can I
Yeah.
speak?
yeah, yeah, sure.
Okay, so ma'am, I have one more question. So for the higher studies, I'm planning to choose a course like data science in healthcare because I have like in my high school I had medical science as my one of the subjects. So what do you think? What is the future of this course, and would it be a good chance if I take this risk?
Of like working on, medical related things and healthcare. Yeah. Is that the question?
Uh, yes, ma'am. It's like data science into the field of healthcare.
Oh, I see. I think that is also a really hot topic right now. I've always really liked it, and I never had the chance to work on medical data and healthcare. And yeah, that is actually a really good field. I don't know. I've like friends that I've seen who are working on it. They seem to be pretty happy. And honestly, I don't know like what the job market would be in the like further future. But right now, I think it's like a really good field to get into, especially if you like it and you enjoy it. Then that's a really good thing. Yeah.
Okay, great.
But
Thanks.
also like yeah, also like don't limit yourselves, especially like because I think most of you guys are undergrads, right? Like you really like some stuff right now. I was like that too, but then when you go to grad school, you see that you also like a whole bunch of other things too. So it's really like don't be afraid of trying different things, and like yeah, don't feel like you have to work on this narrow scope. It's really okay to like jump from one branch to another and until you like figure out what you really like, or even just getting experience in different fields. Like I was a computer engineer. I had a really like in my undergrad I worked on hardware, and then I started like when I started my PhD I started doing deep learning and like privacy, and now I'm doing NLP. So it's totally fine to try different things. So you don't really limit yourself to one topic. Yeah, do whatever you feel like it at any point, and that's okay.
Uh,
I
okay.
saw a question in chat about deduplication.
Yeah, that
Yeah.
was an.
Okay. So, what do you mean? You mean like deduplication in the data, or do you mean like your model is generating duplicates?
Okay, elaborating that. So basically, the data that I had was names and addresses of some establishment, of some entity.
Mm-hmm.
So that can come from more than two or three sources. So they can, for example, if I say that one of these source gives me the name of the institute CMU as CMU and the address, whatever it is, and another source gives me Calgary Menon University. So it's the full form. And similarly, there can be in another source, there can be some spelling mistake as well. So I had really a difficult time approaching this problem. So I was thinking maybe using NLP or wording, I think maybe there is a solution. It just happened.
Um. Yeah, I know that this is a big problem, and have you like I'm not sure. I think so. Let me write this tool down. Spacey. Spacey or NLTK. Just look them up. They have really good tools for just parsing data. So they might have it also like if you Google, I think there should be people who have done this before. Because
Okay,
it is a huge problem. So like
it
yeah,
is.
if you just Google the application for like text pre-processing, there
Okay.
must be something. Yeah, the only things that come to my mind, just I'm almost certain that there should be tools out there. But if there wasn't anything, then the simplest thing that you could do is yeah, maybe like iterate over the data, and like if you see duplicates, just like not manually, but just like brute force over all the data and remove everything. But I don't think you need to do that. I think you're definitely gonna find tools online.
I really did my research on this. So I have read research papers on this, that how people are thinking to approach this, but there is no tool as such. There is something as deduplication.io. They provide a tool, but I have tried it and it is not that accurate. So basically, they train their data online, getting their data and training it online as and when you get the data. So, and with Spacie and NLTK as well. So, I mean, there are basic pre-processing tools,
Yeah,
removing stop words and so on, but nothing of such form.
I, s- I see. I'll yeah send me an email and I'll like ask other people in our lab and see what they do
Yes, sure,
because
sure.
someone has probably done this before.
Okay,
Yeah, yeah. I'll see.
all right.
Okay, so I don't see any other question in the chat. So if anyone wants to unmute and ask any questions to Fatemeh. Yeah. Okay, so I have one question. Like, Fatemeh, what was your journey like? Like, how did you get into research and all that stuff?
Into research in general. So I started research. This is kind of I don't know. It's like funny or it's um everyone in I'm from Iran and I don't know if you have Iranian friends. You've probably heard of like this university called Sharif University because most people who like leave they're from either that university or a couple others. So I'm also from that university, and in like once we get to our third years, most people start joining like advisors and like in research labs and doing research. So that's kind of something that people did, and I was like, okay, people are doing it, and I always liked doing implementing stuff, and I liked some of the courses, so I went and talked to like professors, and I started working with someone. um and yeah, I worked with them for like 1 year, 1.5 year, and it was a very systemsy project. It was like OS related, like nothing about machine learning or anything. It was about scheduling some tasks. And yeah, that's like how I started working. They gave me a project. I wasn't even working with the like advisor himself. I was working with some master's students, and I was also like applying to grad school because I always wanted to be a professor and teach. So I wanted to like apply to grad school, and I applied. And so out of that work I did for my undergrad, we ended up like getting a paper out of it. It was in like a journal, and then I applied. I came here, and I started working on deep learning because my advisor was working on deep learning, and I had no idea what machine learning was. So at the beginning it was really scary for me because I was in a lab with a bunch of people who seemed to be really good with machine learning, and I had like zero idea. So I was really scared, and I felt like I'm never going to learn it. But it ended up being okay. I took a couple courses. I started using PyTorch and working with PyTorch, and yeah, it panned out. So like whenever people are scared of changing fields, I always say that like I did it and it was okay. So don't be afraid. Like I understand that it can be really difficult at the beginning, especially like as an undergrad. You've left your country. You're like you've come to a new country, and like you're doing new things. So it's really scary, but it's okay. Like it's the same way for everyone. So it's not like people have gotten this stuff figured out. No one knows what they're doing. So yeah, anyway, I started working on deep learning, and I was working on like something related to neural network quantization, and we realized that what we were doing would be better for privacy. So that is how I kind of switched to privacy, and I really liked it. I really liked the fact that it was about people, and you have to consider what people are thinking, what's important to them, what they want to protect. So I really liked that. And yeah, I kept doing research on that. And yeah, and then I had like some problems with my advisor, which is again like if any of you guys decide to do a PhD or even a master's, like really research the person that you're going to work on. This is like really important. Work with, sorry. And yeah, I had problems with my advisor anyway. So like 2 years into my PhD, I ended up having to switch advisors, and I started working with a new advisor who's actually an NLP person. So yeah, that was also weird because my previous advisor was like systems person, but like I totally switched to like an ML NLP thing. And again, at the beginning, it was hard, but because I had done this like once before, I was like, it's okay. So I didn't really stress out. And yeah, and still there's stuff that I don't really know as well as I wish, I did, but I'm also still learning. So yeah, that has kind of been my story. And I've been doing NLP for some time now. Yeah.
Okay. So yeah, so I think everyone don't have any queries. So
Yeah, thank you.
okay,
It was really nice. If anyone has any questions, like feel free. And it was really nice. It was nice to talk to you. And yeah, feel free to email me whenever.
okay. So do anyone have any other questions, like anything? Okay, I think we are done for today.
Great. Yeah, have a great day and good luck with your exams. I think most of you probably have exams. So good luck.
You too have a good day. I
Yeah,
think.
thanks.
Yeah, and best of luck for the vaccination.
Thanks. Yeah, I hope not to, yeah.
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 Bye.
Bye bye.